Hello everyone. In the previous video we have discussed vectors. These are the representation of a vector physical quantity by drawing an arrow. The length of the arrow actually represents the magnitude of the vector physical quantity and the arrowhead represents the direction. So here in this video we are going to discuss different types of vectors. So go through the video very carefully and see to that every portion of the video is clear. We are going to discuss different types of vectors. So let us see what are the different types of vectors. The first vector that we are going to discuss is equal vectors. First of all, you see here the vector quantities are represented by vectors like vector A and vector B. You can see here A, at the top of A we have drawn an arrow. It shows that A is a vector quantity and this is vector A. Similarly, vector B is represented by B with an arrow at the top. So two vectors are said to be equal if they have same magnitude and same direction. We all know the vectors are represented by arrow. The length represents the magnitude and the direction is given by the arrowhead. So two vectors are said to be equal if their length is same, that they have same magnitude, and if they are in the same direction. So always remember that when we say equal vector, both the things should be equal. That is, the magnitude should be equal, the direction should also be equal. Okay. Now here we have represented vector A and vector B. You can see here both the vectors have same length and they are in the same direction. So that's why they are called equal vectors. By vector we always mean that it is associated with magnitude as well as direction. So when we say equal vectors, same magnitude and same direction. Now one thing always you remember, if a vector is displaced parallel to itself, suppose a vector is there and it is displaced from its position to another position, and if the direction remains same, that is if the vector is displaced parallel to itself, then the new vector we will be getting will be equal to the previous one. Okay, so always remember when we say equal vector, same magnitude, same direction. Next is negative of a vector. Suppose two vector is there, one is the negative of the other. It means when we say negative vector, it means that the vectors are having the same magnitude but their directions are opposite. That's why we call it negative. Now by negative you can see the figure here. Suppose vector A is there in the direction along x-axis and vector B is of same magnitude, that is the length is same, but the direction is opposite, that is negative x-axis. So we say that vector V is the negative of vector A. Or we can also say vector A is the negative of vector B. So we can write here vector B is equal to minus of vector A. Or we can also write here vector A is equal to minus of vector B. The negative sign shows that vector A and vector B, they have the opposite directions. I hope this is clear to you. Now modulus of a vector. Now in a vector we know that it has a magnitude as well as direction. Now if we simply represent the magnitude or the length of the vector, it is done by putting a modulus sign. Modulus of a vector means the length or magnitude of that vector. Suppose we consider a condition where vector A is there. Now we have taken the modulus. In both the side we are drawing two lines here which represents the modulus of vector A. Modulus of vector A means only the magnitude of vector A. Suppose we write the value of force to be 5 Newton towards west. Now the modulus of this force will be only 5 Newton. the direction won't be there. Same is the case here. In the vector we have magnitude and direction. We are taking the modulus, means it is only the magnitude. A here simply represents the magnitude, or vector A with a modulus sign only represents the magnitude. I hope this is clear to you. Now next we will discuss unit vector. As the name suggests, unit represents 1. That means when a vector is taken and we have to write the unit vector of that particular vector, it is having a magnitude of 1 only and the direction of that given vector. Let me read out the statement. A unit vector is a vector of unit magnitude drawn in the direction of a given vector. Suppose you are given a vector A and you have to find the unit vector of A. Now the unit vector of A will have a magnitude 1, that is for sure, and the direction will be the same as the direction of vector A. Okay? A unit vector in the direction of a given vector is found by dividing the given vector by its modulus. Thus a unit vector in the direction of vector A is given by, see here, this is the way in which we write unit vector: A cap, A hat, or A caret. So these are the different ways in which we speak a unit vector. A unit vector A is A hat, A cap, or A caret. So A cap, which is the unit vector, is the vector divided by its magnitude. We know that a vector has a magnitude as well as direction. What we are doing is we are dividing it by the magnitude. So if we divide it by the magnitude, what will be left out? Only the direction, and the magnitude becomes 1 because magnitude and magnitude cancels out. So unit vector A is vector A divided by its magnitude. Now the magnitude is written as simply A, or it may be written in the form of modulus of vector A. So I hope this is clear. Unit vector means a vector which has unit magnitude and the direction is of that of the given magnitude, given vector. Suppose we are considering here unit vector A, so the direction of unit vector A will be in the direction of vector A. Only difference is it will have a magnitude 1. And how do you obtain it? Vector A divided by the magnitude. You can see here the vector A is represented by the magnitude into the unit vector. As we have just now defined, unit vector has a direction only and the magnitude is 1. So magnitude 1 and the magnitude of A, they multiply here and we get a total which is vector A. Vector A is the magnitude into the unit vector. As we have written here, vector A is equal to unit vector A, that is A cap, is equal to vector A divided by modulus of A. So if we want to write vector A, it will be modulus of A, that is magnitude of A, into the unit vector which is given here. I hope this is very clear to you. This is very, very important. Unit vector, you have to always use it. Now one more thing which has to be noted, that the magnitude of unit vector is always unity. It is just to give the direction of a vector. Its magnitude is always same, which is 1. A unit vector has no units or dimensions. We will not represent a unit vector with some unit or dimensions, right? Okay. Now the next vector that we are going to discuss is fixed vectors. The vectors whose initial point is fixed is called fixed vector or a localized vector. For example, we have already discussed position vectors. Position vectors, we have seen that the value of the position vector, its initial position is always fixed at the origin. So it is called a fixed vector. Now next is free vector. A vector whose initial point is not fixed is called a free vector or a non-localized vector. For example, the velocity vector of a particle moving in a straight line is a free vector. You know, when a body moves, now the velocity of the body, if you want to represent with a vector, now this vector will not be fixed. It will be moving along with the body because the body is moving. So its velocity vector will be moving along with the body. So that kind of vector is a free vector which moves, which is not fixed. Now the next is coplanar vector. As the name suggests, coplanar means having the same plane. The vectors which acts in the same plane are called coplanar vector. Take an example. Suppose you consider the xy plane in a coordinate system. Now if we have vector A, vector B, vector C in the xy plane, then all these vectors will be considered as coplanar. I hope this is clear. Next type of vector that we are going to discuss here is collinear vector. The vectors which either act along the same line or along parallel lines are called collinear vectors. Two collinear vectors having same direction, that is angle between them will be 0 degree, are called like or parallel vectors. Two collinear vectors having opposite directions, angle which is 180 degree, are called unlike or anti-parallel vectors. Let me make it clear by using the diagram also. See here, these are all the examples of collinear vectors. Like here you can see vector A and vector B, they are in the same line, along the same line, and here vector A and vector B are parallel to each other but along the same direction. So here the angle between AB and here also the angle between AB is 0 degree. So these collinear vectors, AB is collinear, here also AB is collinear, and they are called like or parallel vectors. At the same time, you can see another example here where A and B are acting along the same line but in the opposite direction, making an angle of 180 degree. Or you can see they are anti-parallel. They are in the opposite directions, not acting in the same line but along the opposite direction and parallel to each other. So the angle is again 180 degrees. So these kind of collinear vectors are called unlike or anti-parallel vectors. Okay. Now the next type of vector, co-initial vector. As the name suggests, co-initial means same initial point. You can see vector A, vector B, vector C, they have the same initial point O. So these vectors A, B and C are co-initial vectors. In the same way, co-terminus vectors, that is the vectors which have the common terminal point, that is the end point, are called co-terminus vector. You can see in this figure vector A, vector B and vector C, they have the common terminal point, that is common end point, and that's why they are called co-terminus vectors. So I hope the concept of different types of vectors are clear. Go through the video if you have any doubt in any of the particular type of vector again, and see to that everything is clear. If there is any doubt which is left out, you can post me the doubts. Thank you.